The disjunctive normal form was discussed in our reading this week in section 2.2 of Logic and Circuits. The main purpose of this reading was to explain disjunctive normal form, also referred to as DNF, and then also explain how we use DNF when we're creating circuits. This passage explains both of these ideas, but also shows examples of both of these ideas, which is something we will continue to do in this presentation. So what exactly is disjunctive normal form? DNF is a formula of disjunctions, which are or statements, of conjunctions, which are and statements. And they're in their simplest form, so they are atomic sentence letters. The disjunctions and the or statements are used to break up the conjunctions, which are the and statements, and kind of leave us in that simplest form. It is useful. The DNF form helps us to understand which combinations of a statement will result in the entire formula being true, because it's already broken it down and it already knows and shows what those statements are. Here's an example. Okay, so this statement right here is an example of a DNF. Really, basically what that DNF is doing is going through this whole truth table, which is found right below, and going through and using only the statements that lead to a true conclusion. Okay, so how do we make DNF into circuits? How do we transform the idea of DNF, and how do we utilize the benefits that it gives us, and how do we transfer all of that into making circuits? Here are the steps that the reading outlines for us. First, we determine the number of inputs and outputs required by the circuit and assign a sentence letter to each input. Second, for each output, we write down all combinations of inputs that should make the output equal to 1. Third, for each output, we write down a logical formula in full DNF where each disjunct will correspond to one combination of inputs that makes the output equal to 1. Fourth, from each of these formulas, we construct a circuit diagram, substituting the appropriate gates for the logical connectives. That's a lot of information. Good thing the reading provides us an example. We're going to walk through that example right now. Okay, so the example that the reading provides us reads like this. Design a circuit to run an automatic sprinkler system. The system should come on only at night unless a rain gauge indicates that there was rain during the day. But even if there was rain during the day, one can also trigger the system manually, though still only at night. 3 wires enter the circuit. The first carries a 1 if the light sensor indicates that it is nighttime. The second carries a 1 if the rain gauge has detected rain during the day, and the third carries a 1 if the system has been manually overridden. The circuit turns on the system by sending a 1 on its output wire. So we have N equals nighttime, R equals rain, M equals manual, and T equals trigger. So we will go on to construct a table like this. This table has all the values for the inputs, and it leads to all the outputs. This is just a visual outlining what outputs equal 1 with what inputs. So we see that when N, R, and M have 1, an output is 1. When N has 1, R has 0, and M has 1, the output is also 1. When N has 1, and R and M have 0, the output is also 1. And we see that all of a sudden, instead of constructing all of these in a circuit, we're just going to focus on these 3. We see that the DNF form utilizes these 3, which are equivalent to these 3 ideas, where we have the N and R and M equaling this first line, where we have the N and the negation of R and M equaling the second line, and the N and the negation of R and the negation of M equaling this third line. So now that we have our DNF form, we can go and start constructing what the circuit will look like. We start with our inputs, N, R, and M. Those are highlighted in the orange circle right there. Then, after creating all the different scenarios in a way, we see our conjunctions. These are our first set of conjunctions. We then continue to make our second set of conjunctions, which leads us to make an OR gate which disjoins the first two main disjunctions. And then we make another OR gate that disjoins the disjunction with the third main disjunction. Then we have our completed circuit, which shows this area over here leading off where t equals 1, so where the system is triggered. So that area, all of these conjunctions, there are so many different ways throughout the circuit that we can get t equals 1, or where we can get the system being triggered. In essence, what the DNF does is simplify this whole circuit. It makes it so that way we can understand what ideas lead to us getting a triggered value. There's more in the other sections about how to make a circuit and what all the different shapes mean, which is discussed further in all of the different sections that are talked about today. So I hope this clarified what DNF form is and just kind of overviewed it, but if you have any questions, I will be on the discussion board.